Start. Welcome everybody. So welcome to the presentation of Septentrio. My name is Stef, Market Access Manager at Septentrio. And today we talk on FIRA, on heading orientation and GNSSINS for agriculture robotics. And last year was a major success, actually, the FIRA. So I'm very happy that they opened up today again. With the presentations and with the 1 day of booths and connecting with each other. So let me start with Septentrio. Who is Septentrio? Septentrio is global leader in GNSS systems. We have a worldwide team of more than 120 people. Actually, the vast majority of Septentrio is R&D. And you are represented actually all over the world, meaning that we don't have only sales offices all over the world, but we also can provide local support, which comes in very handy, of course, during these travel restrictions with COVID. Our key pillars are accuracy, reliability, availability, and security when we look at the core GNSS side. So if we look at what does Septentrio do, we do not only assemble GNSS receivers with external components, but we really make our own chipsets. So we make our own reference design chipset and we make our own positioning engine. And from these technologies, which we put in, we can make products, of course, and we have a product family on the module level, but also on board level, and also house receivers, so ruggedized receivers, which are, for example, IP68 weatherproof. If we look where Septentrio coming from, Septentrio founded in 2000, so 20 years ago, as a spin-off of IMEC. We actually are already since 2003, we supply towards for the agriculture business. Back then it was SBG, which was part of Raven. Now it's called Raven. And we already supplied back then auto steering and farm equipment for GNSS systems for auto steering and farm equipment. In 2016, we started supplying with GNSS solutions for NIO. Well, really a leader, I would say, in the ag robotics, of course. But with the big boom of ag robotics, we started supplying more and more to other robotics companies like a CETIA or an EarthSense, and well, still more to come, of course. Septentrio, where we are represented, actually we cover a broad range in the market, but we are always represented in critical applications, so either in critical environments. If we look at machine automation, of course, in the agriculture business, but also in the port automation, logistics, marine, rail, all kinds of applications. Also, survey and mapping is a big important business for us on the survey side, but also on the UAV side. And then, of course, our core lies in the scientific world, where we are, of course, a market leader for timing receivers, for example, but also for reference stations. So I'm not going to explain the whole slide here, but just a few major trends in agriculture. In agriculture in general, we see more and more move towards autonomous. So we started, of course, with guided systems, going towards steering systems, and now more and more autonomous systems are coming up because of the sensor fusion and the involvement of SLAM algorithms and the integration with vision systems. This is all possible. Connectivity is a very important part. Swarm collaboration, so swarm tasking, kind of vehicle to vehicle communication on the field is a very important trend. Of course, accurate localization with the correction services which are needed sometimes on the RTK side or SSR. And then ease of use is also a big important factor in the agriculture business. You want to have a decent workflow on the customer side, but also, for example, access remotely of your receivers. So our receivers are accessible remotely, meaning that you can troubleshoot from a distance, or you can configure the receiver from a distance, which comes in very handy, of course. And then the robotic side, well, everybody here is known to the ag robotic side, of course. In the robotic side, we see accuracy and orientation are massively important because of the single plant analysis, but also coping with difficult environments in general. GNSS signal obstruction because of high crops, for example, maintaining heading. We have a few options how to do this. So you have velocity or course over ground. Velocity course over ground brings some troubles with it. For example, a downside of this is when your vehicle is moving differently dependently from your heading. So let's say you have a spraying or an arm which doesn't move in the alignment of the wheels, or the wheels go sideways, then of course it's not a perfect solution for your heading and your orientation. If you look at the magnetometer side, then yes, this could be an option, but because of the compassing and the interference with magnetic fields, this is always a little bit tricky, especially when you have a modular robot. You want to adapt something on your robot, you need to recalibrate it. It's not always trivial to recalibrate or to calibrate actually an IMU, for example, with a magnetometer inside. So it's not a perfect solution. And also actually worldwide around the globe, you have different magnetic fields. So you need to store this in your devices. Gyro compass, commonly used actually in marine, for example, often used with fiber optic gyros also, but it's actually a large power consumption, so not ideal for robotics. It's not swap at all. It's often a bigger device, so it doesn't really fit with the robotic side. We zoom in a little bit more on dual antenna and GNSSINS because these are the main drivers actually on the ag robotic side if we look at orientation, heading, and positioning in general. So a small table on which application for which methods. Well, you see clearly that robotics and autonomous systems are actually a best fit with dual GNSS and GNSSINS. So if we look at dual antenna, then dual antenna GNSS actually solves a lot of problems. For example, it's way better than velocity heading. Why? Again, because when you have slips on wheels or when your wheels turn sideways, then you lose your course over ground a little bit. And the direction of aim of your actionable parts could be different from your heading. So a dual antenna will solve this problem. The same with, it's very independent on the magnetic interference. It doesn't have any interference of magnetic fields, meaning that it's a good use when you have a lot of metal products or motors around your vehicle. Yes, again, you can calibrate for these kind of things, but when it's not homogeneous, so when you pass by a tractor or anything, then your heading is pretty much off. So it's not a perfect fit to do it with the magnetic side. So a dual antenna will solve this problem. It maximizes really your heading accuracy and stability because you have two sources actually of info creating a sort of baseline, and you get a very precise heading. And it's ideal for off-road. I mean, with certain vibrations, which we especially have in ag robotics, of course, because of the bumpy areas where we drive along in the field. The dual antenna doesn't have any troubles with the vibration environment. So it's eliminating actually all these problems around vibrations. It also works very well in slow dynamics. Slow dynamics is always a little bit of a problem, especially when you look at an IMU side. You need movement, but also course over ground. You need a certain direction and a certain movement. When it's too slow, then this heading is not reliable anymore. So a dual antenna doesn't rely solely on the kinematics. So it's a very good fit actually to eliminate the problems in slow dynamics. I want to zoom in very quickly on the Mozi H we have. It's a module level GNSS receiver. It's very small, very lightweight, low power, and it has a dual antenna, and it's actually extremely precise. It's below 1 centimeter. It's a newer addition, actually the latest addition to our whole Mozi family or a whole module family. So if you need a module level GNSS receiver which has heading, then take a look at the Mozi H. It could be a very good unit for your ag robot in general. So then we look at GNSSINS. In GNSSINS, we have, of course, the sensor fusion part is most critical here. Some companies try to do it themselves, so taking separate IMUs, taking separate GNSS systems and fuse it themselves. The problem here is that it's not very trivial to do this. You need a lot of knowledge on the timing synchronization. Many things can go wrong on the behavior side of the IMU. And it's also, it's just difficult to do this. It takes a lot of time and even cost to make a sensor fusion. You need to maintain it also. So it's always better, well, it's better if you want to focus on your customer base, if you want to focus on your own core of your business, then it's better to take a unit like an INS, GNSS from a vendor or supplier. If you look at the IMU side, you always have the problem, of course, with absolute positioning and heading, which you don't have on the IMU side. You calculate a yaw, but this can drift. Yes, you have periodic drifts, so you can calibrate for this, but it's not very reliable. So if you look at the GNSS side, then when you have obstruction or signal loss, you need to dead reckon, of course, and this is not actually possible without an IMU. So the GNSS side has a lot of advantages on the heading side, but it's not perfect for your roll and pitch, and it's not actually perfect for dead reckoning, of course. If you fuse them together, you get a very nice product and a very nice solution. And that's, of course, in the middle, the INS solution, which gives you a very absolute positioning, an absolute heading, and it has no drift at all inside their solution. So then if we look at the baseline of the solution, so this could be important, but be aware that even when you have a smaller robot, below 2 meters, you can play around with the baseline and the accuracy of it. But if you go above 2 meters, you see a very decrease of error margin. So it doesn't bring a lot of more actually when you expand this baseline over 2 meters. When you have a very compact robot and you don't have a lot of space in there, you can always use an INS version, of course, because an INS heading makes it sort of independent of the baseline, which is a perfect solution actually for a smaller robot where you don't have a lot of space. So if we look at the reliability, Septentrio has several technologies built in their GNSS receivers, especially in critical environments. You can trust the signals at all times, but also integrity level is massively important, especially when safety comes around. Then you need a good integrity level. So it's not smart to save cost on these kind of things, but already look at the future and look at certain certifications, which are also coming up in ag, also in ag robotics, of course, eventually. So be aware of this integrity level when you buy a GNSS unit or you test a GNSS unit. We have all kinds of technologies built in, like Iona Plus. It does a scintillation monitoring. At the moment, we don't have a lot of solar flare issues, but in the upcoming years, this becomes an issue again, and especially around the equator, this is a big problem. So when you have an autonomous robot, you need to withstand these kind of interferences. Do not damage what you value. So consider your liability. I mean, cost savings versus operational excellence. You don't want to damage your crops. You don't want any accidents in your field with people maybe, or anything else with animals. Don't save a couple of €100 for an INS or a GNSS unit, or maybe even an IMU unit, but really go for this operational excellence inside. And then, of course, maintain position and orientation. It's critical. We have a very good dead reckoning, which is, of course, very good for the robotic side for ag. Then we have a very new addition to the family. This is actually launched today. So FIRA has the greatest pleasure actually to have this as a first launch. We have added the Ostrich I3 to our portfolio. We have a ruggedized version and a board version in there. All kinds of additional features, of course, next to the perfect dead reckoning algorithms and the centimeter accuracy. We also have velocity input. You can configure your PPS pulses. We have several event markers in there. It's on the ruggedized version. It's of course weatherproof, and the board version comes with a robotics interface board, for example, ideal for actually development on your own robot. I would say take a look at it. The press release is also at FIRA, and it's online since today, also on our websites. But if you have any questions, don't hesitate to come to the booth about this product or any other product, of course. And we are happy to explain you more or to support you on your questions on this. Just a very short overview of all the GNSS products we have. Again, the module levels, a dual antenna, single antenna, even a correction module level where corrections are included. So you don't have this hassle anymore, maybe on the customer side. Worldwide, you have different kind of correction services, and sometimes on the customer side, this can bring a different problem or a certain hassle which you don't want as a robotic supplier. We have boards, of course, several versions of it, GNSSINS boards, also with a dual antenna inside. We also have a tethered version, also of the new i3, which can come in handy when your vehicle alignment is different from your point of interest. So when you need your IMU to be installed somewhere differently, or you don't have any space for the board itself, then you can detach actually the IMU from the GNSS receiver, which gives you a lot of freedom in your design and architecture. Of course, we have several, again, robotics interface boards, which could come in handy, and of course, a smart antenna where everything is stacked together. So this was actually the brief overview and a brief presentation. When you want to do a free drive testing, then feel free to let us know. Send us an email, or my email address is up there. Mention that you saw us at the FIRA. What you could also do is, of course, come to the booth and ask some questions. But don't hesitate to reach out when you want to test something or discuss what kind of GNSS or INS fits best for your application. I don't know if there are any questions so far. I don't believe so. Emma, can you check? We have no questions. I think everything is handled here. So then I want to thank you all for your attention. Please don't hesitate. I'm present at the booth with my colleague. If you have technical questions or any other questions, let us know, and see you next time.